So in this video lesson, we'll be solving equations with rational exponents. So before we get into actually solving, let's consider what we know about rational exponents. The first thing we need to know, when you have a base raised to an exponent that's actually a fraction or a rational exponent, it is equal to the root power or the denominator of the rational exponent is the root power of the base raised to the power of the numerator in the original fractional exponent, okay? So we're going to use this understanding here. Let's look at some examples on the next slide. So each one of these is a base raised to a fractional exponent. So let's consider what they are. This first one, x to the 3/3. Well, that's going to be the cubed root of x squared, okay? The second one, x to the 3/5. That's going to be the fifth root of x cubed. We could write it out as the fifth root of x to the third power or cubed. And finally, this last one, x to the 5/2. Well, that's going to be the square root, which we could simply just write as the square root of x to the 5th power. All right. All right, so keep that in mind as we work through our examples. Okay, let's also recall that when we have a problem, an equation like this, where we have the square root of x equals 5, the way that we solve for x, the inverse of the square root is to square. So we would square both sides, and we would see that x equals 25, okay? Well, let's remember what I just showed you. If x to the 1/2 is equal to the square root of x, okay? So this is what I just taught you. Remember the 2, that's the square root of x to the 1 power. Well, if we were going to solve this for x over here on the right side, we would, what we just talked about, we would square this side. Well, we would also square the left side. Well, what I want you to see is what happens when we have a base to a fractional exponent and then we raise it to the reciprocal of that power, x to the 1/2 to the power of 2. And let me show you that over here. So again, we have x to the 1/2 that we're going to raise, or that we're going to square. So it's x to the 1/2 times 2/1. Well, that's going to equal x to the 2/2, which is the same as x to the 1, which equals x. So that x gets you right back to this x. So what I'm doing all of this to show you is that when you're working with an equation that has a fractional or a rational exponent, you can clear those out by raising that to the reciprocal power. So the reciprocal of 1/2 is 2/1, and that gets you right back to x. So we're going to use that when solving these equations. So let's solve a few of these quick examples. If we have x to the 1/2 equals 8, again, this fractional exponent, we're going to raise it to the reciprocal power of 2/1, which is 2. So basically, we're just squaring both sides. This side is going to be x equals, and then 8 squared is 64, okay? And if you wanted to check your work, you'd plug 64 in here, and it says 64 to the 1/2, and you're checking, does it equal 8? Well, I just showed you that 64 to the 1/2 is the same as the square root of 64. And the square root of 64 is 8, and it checks. Okay? So x to the 1/3 equals 5. Well, if we're solving for x over here, the way to cancel out the 1/3 is to raise to the reciprocal power, and that means we would cube it. And we would cube this side, okay? And 5 cubed, 5 times 5 is 25, times 5 is 125. So x equals 125, okay? And on this last example, x to the 3/2 equals 27. Well, again, if you're trying to solve for x over here, we're going to raise this to the power, to the reciprocal power, which is 2/3. So we're going to have to raise 27 to the 2/3 power. So on the left, we have x equals, because these basically canceled each other out, okay, equals 27 to the 2/3 power. Now, you can work that out on your calculator, but you also know that it's equal to the cubed root of 27 squared. Well, you can do that a couple ways. You could do the cube root of 27 first, which is 3. And then 3 squared is 9. So you know x equals 9. Okay, so let's solve this equation that has a lot going on, including a rational expression. We're going to solve it, and we're going to check our answer for extraneous solutions. That just means to check your answers to make sure they work. Okay, so 2 times x plus 3 to the 4/5 power minus 1 equals 31. Just like any equation, we're going to start working it out till we can isolate the x. First thing is to remove this minus 1, which is we're going to add 1 to both sides. Okay, when we do that, our equation is going to be 2 times x plus 3 to the 4/5 equals 32. Now, all of this is being multiplied times 2. So I'm going to do the inverse, which is to divide by 2, to divide both sides. Now my equation says x plus 3 all raised to the 4/5 power equals 16. Okay, now I have this x plus 3, this binomial, raised to the 4/5. Remember that we can get back to x plus 3 if we raise all of this to the reciprocal power, which would be to the 5/4. So all of this to the 5/4, and therefore 16 to the 5/4 power. All right, well, when we do that, on the left side, we're just left with the x plus 3, because basically this became 1. On the right side, 16 to the 5/4, well, that's going to be the 4th root of 16 to the 5th power. Now, you can work this out on your calculator, okay? By the way, on your calculator, there's a button that says math, and when you click that button, one of the options will be something that looks like this. That's where if you select this button, you can make this anything you want it to be. And you would obviously plug in a 4 and then put 16 to the 5th power, and it would work it out for you, okay? But let me show you how you can also work it out. So the 4th root of 16 to the 5th power, there's 2 ways to solve this. You could do 16 to the 5th first, and then find the 4th root of that. So you could do this first, or you could also do the 4th root of 16 first, and then raise it to the 5th power. That's what I'm going to do because the 4th root of 16 is actually 2. Because 2 times 2 times 2 times 2 equals 16. Now notice that it could also be negative 2 times negative 2 times negative 2 times negative 2. All right. So what we're going to have is x plus 3 equals plus or minus 32. By the way, the 32, that's because when I did the 4th root of 16, I got plus or minus 2, and then I raise it to the 5th power. Okay, so the 4th root of 16 was 2, and then 2 to the 5th power is 32, but I could have used a negative 2 as well. So plus or minus 32. So to ultimately solve this one, I have one equation that says x plus 3 equals positive 32, and x plus 3 equals negative 32. So one of my answers is x equals 29 and x equals negative 35. Now we need to check both of these answers to make sure that they are correct. And when you check both of them, they do both check out. So both of those would be our solutions. Okay, another example. So in this example, we have x minus 4 to the 3 halves plus 5 equals 13. So first thing I'm going to do is subtract 5 from both sides. And I end up with x minus 4 to the 3 halves equals 8. All right, so if x minus 4 is being raised to the 3 halves, we can clear that out by raising it to the power of the reciprocal, which is 2/3. That means we have to raise 8 to the 2/3 as well. So on the left side, we're just left with x minus 4, because again, 3 halves times 2/3 gives you 1. So x minus 4 equals, and then 8 to the 3 halves. Remember, that's the cubed root of 8 squared. Cube root of 8 squared. You can work this out on your calculator, but the cube root of 8 is 2, and 2 squared. So again, I'm working it out this way. The cube root of 8 is 2, and then 2 squared is 4. So my equation is x minus 4 equals 4. So then I add 4 to both sides, and x equals 8. And that is our only solution. The reason I know that is because we're talking about the cube root of 8. The cube root of 8 can only be 2. It's not negative 2. Because negative 2 times negative 2 times negative 2 would actually give you negative 8. So anytime your root power is an odd, you're only going to get one answer. When it's an even, you get the 2 answers, and you have to check them. All right? Let's take a look at one more example for this video. Okay, in this example, we have x plus 3 to the 1/2 equals x minus 3. Okay, so we're trying to isolate this x. We can get rid of this 1/2 by raising it to the inverse exponent. So instead of 1/2, it's 2 over 1, which we could just put 2. So we're squaring both sides. On the left side, of course, we're just left with the x plus 3 equals. On the right side, we have this x minus 3 squared. Well, I'll go ahead and write it out. That's x minus 3 times itself, or x minus 3 times x minus 3. So you're going to have to FOIL this first, outside, inside, last. When you do that, your equation is going to say x plus 3 equals x squared minus 6x plus 9. Okay. Now what we're going to do is we're going to put all these like terms together on the same side and set the equation equal to 0, and then factor it to determine our answers. So what we're going to have to do is we're going to have to subtract 3 from the left side and from the right side. That would leave us with x equals x squared minus 6x plus 6. But then we're going to have to subtract x from both sides. So we're left with 0 equals x squared minus 7x plus 6. Now from here, we're going to have to factor this quadratic. So remember, we're finding the factors of a times c, or 1 times 6, which is 6. So the factors of 6 that equal -7, well, that's -1 times -6. So our factors are x minus 6 times x minus 1. And if you set both of these equal to 0, x minus 6 equals to 0, well, then x equals positive 6. And over here, if you set x minus 1 equals 0, then x equals 1. But now we need to check both of our answers to make sure that they satisfy this equation. And you can see when you plug in your 6 and you work it out, it does satisfy the equation. So that is one of our solutions. But when you plug in the 1, it does not work out. So that is our extraneous solution. So x equals 6 is our only solution.